In our previous video, we solved an equation, two equations into unknowns using the Gaussian elimination method, and at one point we got this augmented matrix. That means it's a matrix, but it's somewhat what would you say now? Somewhat complex, right? Glorified. But here, just as a reminder, when we wrote this back in equation form, we had 4x plus 6y equals 56, and then 0x plus 1y equals 6. So we know that y is equal to 6, and then we put 6 here and got 4x plus 6 times 6, 36 equals 56. X would be 56 minus 36. No, 4x would be 56 minus 36, which is 20. So 4x equals 20, so x would be 20 over 4, which is 5, right? You remember that? Now, the method of writing the matrix in what they call row echelon form. When they talk about row echelon form, you really want a number here, call this number 1, number 2, number 3, and a 0 here. Alright? For the 2 by 2 matrix. Oh, no. Let me do that again. 1 here, a number here, and a 0 here. Right? That's what it should be. Right? So, that is what they're talking about. They talk about row echelon form, and the answers, okay, you call it A1, A2, right? I should put in the answers. So this is what they're talking about when they say row echelon form. And then reduced row echelon form is when you have this number as a 0. But the thing is, you would want to write the matrices in those forms in an exam unless you're asked to do so, because you're looking at more work, meaning more time, right, needed to work. But let's make this 4 into a 1. What do? We keep row 2 as it is. Row 1, it has a 1 here already. Let me draw the line here. It has a 1 here already, and this is 6. So here, we're going to say row 1 divided by 4. I could have written it as a quarter row 1. Alright? Same thing. Row 1 divided by 4 will lead to our new row 1. So 4 over 1 is 1. 6 over 4. 6 over 4 is the same as 2 into 6, 3, 2 into 4, 2. And then we have 56 divided by 4, which is 14. Right? So that's what we have. So in this case, what you would write is 1x plus 3 over 2y equals 14, and 0x plus 1y equals 6. So you know that y is 6. So x plus 3 over 2 times 6, 2 into 2, 1, 2 into 6, 3, 3 is 9, equal 14, and x is equal to 14 minus 9, which is 5. Alright? So there, you're dealing with smaller numbers when you do that. Only thing now is that you have sometimes end up with fractions in it. right? But it could still be worked out anyway. Then here, if you want to turn this into a 0, then things would become even more complicated, right? Now, let's go back up to our original equation that we had. I want to turn the 6, the second element in row 1 into a 0. That means even more work. You have 4, 6, 56. You keep row 1 as it is. What I want to do is turn this into a 6 and then subtract these two 6's. The new 6 from the 6 up here. So I have row 2 times 6 will lead to the new row 2. 0, 6, 0, 1, 6, 6, 6, 6, 36. Then after that, I say I want to change row 1. So row 1 minus row 2 will lead to our new row 1. So 4 minus 0 is 4. 6 minus 6 is 0. 56 minus 36 is 20. And we keep our row 2 as it is. Then what we want to do is turn 4 into a 0 and 6 into a 0. So in the next step, what we will do is say row 1 divided by 4 will lead to our new row 1. So 4 over 4 is 1, 0 over 4 is 0, 20 over 4 is 5. Then row 2 is divided by 6 to lead to our new row 2. And we say 0 over 6 is 0, 6 over 6 is 1, 36 over 6 is 6. And this automatically will give you the answers for x and y. Right? So we're going to say 1x plus 0 is equal to 5. When we change, remember this is 1x, right? And this would be 0y, but you would need to have it there equals 5. Then we would have a 0x, we would need it, plus a 1y. So our 1y will be here. So you just write y equals 6 would come here. So you get x equals 5, y equals 6. So that's if you're asked to write in row echelon form or reduced row echelon form, or if you just feel like you want to reduce the matrix in those forms, then you could do that if you have enough time. Alright, so that's it. I'll see you in the next video.